We were asked to show the following simplifies to something quite beautiful. Our golden rule when dividing fractions is to remember KCF. K stands for keep. We keep the first fraction. C stands for change. We change the divide into multiply. And F stands for flip. We flip the second fraction. We love multiplying as we just multiply the tops and multiply the bottoms separately. Before multiplying, I'm going to factorise the top and bottom of each fraction where possible. Look at my first fraction on the top here. If I've got two terms, I always try single brackets. I want the highest common factor from both terms. Look at numbers. Here I've got 7 and 14. Well, the highest common factor in 7 and 14 is number 7. Here we've got x. Here we do not have x, so it's not common. So now open my single bracket. What do I times 7 to get back to 7x? I'm missing x. What do I times 7 to get back to negative 14? I'm missing negative 2. On the bottom, as I have three terms, every time I see a plus or minus, it's a separate term. Three terms are quadratic in terms of x, as I have x squared. We'll factorise into double brackets. As it starts x squared, each bracket will start with a single x. Our rule is we need to find two numbers that multiply to give us the number term, in this case negative 12, and the same terms must still add to give us a number in front of the single letter, in this case positive 4. The only way to get a negative when multiplying is to have one positive and one negative. Listing out the factors of 12, we'd have 1 and 12, 2 and 6, and 3 and 4. Only one pair will work. In this case, the only pair that multiplies to give us negative 12 and adds to give you positive 4, in this case, is the 2 and the 6. As you want positive 4, therefore has to be plus 6 and minus 2. Leaving the multiplication sign alone, factorising the top on my second fraction. If I see two terms, again, I always try single brackets. I want to take the highest common factor from both terms. In this case, the highest common factor in x cubed and negative 36x is in this case single x. Opening my single bracket, what do I have times x to get back to x cubed? Well, I'm missing x squared. What do I have times x to get back to negative 36x? I'm missing negative 36. But I should now recognise this on the inside as being the difference of two squares. As I have a squared term, must be subtract, which it is, another squared term, as 36 is 6 squared. Hence, leaving the single x alone, I'm now going to factorise x squared minus 36 using difference of two squares. So I'm going to start with my double brackets. What times itself gives us x squared? We know x and x. Well, 36 is 6 squared, so it's going to be plus 6 and minus 6. And on the bottom, I've got x minus 6. If you've got two terms and there's nothing common, I can still place that inside single brackets. So that's the same as having brackets x minus 6. I'm going to check each fraction for any common factors. Look at my first fraction. Here I've got x minus 2 in brackets on the top and bottom. So I'm going to cancel that. So doink and doink will cancel. Look at my second fraction. Here I can see I've got x minus 6 common in brackets on the top and bottom. So doink and doink. Now multiplying whatever's now left on the top and bottom. On the top here, I've got 7 multiplied by x, which will give us 7x. And we're still multiplied by single brackets of x plus 6. On the bottom here, I've got x plus 6 multiplied. This is cancelled, so the number's just 1. Well, x plus 6 in brackets times 1. That's just simply x plus 6. Again, checking for any common factors. Here I can see I've got x plus 6 common in brackets on the top and bottom. So I'll cancel that. So doink and doink will cancel. Hence, my final answer is quite beautiful. Is simply 7x.